Hello and welcome everybody to our today's workshop about the graph. Today we are going to take an in-depth look at the graph network, which is designed to help you in better understanding what the graph is, what the graph does, and how the future of the graph could look like. I'm Stefan and I'm the founder of the Graph Academy, so let's get started with this workshop. So first of all, let's ask ourselves, what is the graph and what does the graph do? In a really simple way, you can consider the graph as the Google of blockchains. Now, this comparison is not 100% accurate because the graph is not designed for end users, but for machines. But in one way, the graph is organizing data of blockchains. And as such, the graph is a decentralized indexing protocol for Web3 applications. And the graph indexes data from various different blockchain networks, such as Ethereum, Arbitrum, Base, Phantom, Solana, and whatever blockchain there is out there. And in doing so, the graph makes the data of all these blockchains easily available for different applications, for developers. But what is the problem that the graph seeks to tackle with its mission? And that's where we step into the dangers of centralization. So let's focus a couple of slides on the problem that the graph is tackling and the problem we are confronted with the present day internet. So the present structure of the internet highly favors centralization. It is a client-server architecture that bestows unprecedented power to the organizations that are running the services, but also the servers that are powering the internet as we know it. If you think about the power that Google has, that Amazon has, that Facebook has, it's never been in our history that organizations had so much power, centralized power. And with this kind of power, these organizations are able to define all the rules, they can control all the data, and they also, which is perhaps even the worst thing about it all, they can grant and revoke access to their services at their own discretion, which is pretty bad. It's not free data and it's very centralized by these monopolistic players in a market. And this kind of centralization is causing information asymmetries in the market. So as a natural result of the centralized server architecture that we've just discussed in the previous slide, is that users are not aware how their data is used and whom this data is given access to. So you have a lot of free services on the internet by large corporations that are able to provide their services entirely for free to you, but at the same time they are using your data. You don't know how this data is used, but it is used in some kind of way. And not allowing their users to have a say in how the data is used obviously creates information asymmetries and causes power imbalances between the users and these monopolistic services. So centralized organizations have really created tightly interwoven structures on the internet and are not willing to give the majority of individuals that are using these services the ability to impact how things function, to have a say in these services. And it's somehow like people have become passive observers in a world where they are unable to change and do not have a stake in these services. So these monopolies make it really hard for individuals to contribute their talents because they are closed to the outside public. They are not open source. And people are given all or nothing deals. And the competition is stifled in these kind of environments, and the freedom of choice of the individual disappears. Now, I found this really interesting quote by Tegan Klein, who is the CEO of Edge and Node, which is one of the core developer teams of the graph. And what she said was really interesting because she said the graph organizes data in a decentralized way. You could think of what Google does. The graph does that, but instead of there just being one company that can own and control and change the data, or potentially even pretend the data does not exist, the graph has over 200 Google-like companies that are independent all around the world. And you can already see that there is a very, very influential tone of decentralization, of not having a centralized entity in the graph ecosystem. This also comes with the advantage, of course, if one player, one indexer, one of these 200 Google-like companies that are participating in the graph network, if one of these companies should fail or leave the network, this wouldn't affect the network because the network would still continue to run. In contrast to a centralized service, where if the centralized service goes under, the entire service and all the employees, all the network is going under the water, so to speak. But what is the vision of the graph? At its core, the vision of the graph is to enable applications that are fully powered by public infrastructure in a decentralized manner. So this kind of full stack decentralization helps to create community-owned organizations. And these organizations are resilient to the failure of individual businesses because they are owned by the community. And with this never before seen level of interoperability, these decentralized applications are robust enough to prevent rent seeking and will help developers and users to know that the time they invest in these networks is not lost, and actually that they have an actual stake in these networks. And even though we have seen in the past a rise in decentralized applications, dApps, which is admittedly really great, and it's great news to hear that, but most of these decentralized applications are not fully decentralized. So they are only decentralized in the bottom layer of the stack, for example, the blockchain. And these dApps are still being operated by centralized organizations or even businesses, and for this reason are at the risk of rent seeking or business failures. So even if a blockchain is decentralized, if there's just one single entity operating this blockchain, the blockchain will eventually fail. And for the graph's vision to come to fruition, there needs to be a shift away from business financing the development and maintenance of applications towards a more decentralized world in which users are paying decentralized networks directly for granular access to these resources. So let's have a quick look at the different roles and participants within the really large graph ecosystem. So depending on the technical know-how and the risk confidence and also the desired activity level of a given participant, you can choose between a variety of different user roles. And in the following, we'll take a look what these roles are and to help you in better understanding how these roles function and how they are participating to the graph network. So on one hand, you have consumers. These data consumers are paying indexers for being able to query data from the graph network. These data consumers are typically end users, but could also be web services or middleware that integrates with the graph. Then you have indexers, and indexers are node operators, and they index data on the blockchain to make it available to data consumers. Then there are also curators, and these curators are using GRT tokens to signal to indexers which kind of subgraphs are attractive and interesting so that indexers know which kind of subgraphs to index. And last but not least, there are delegators who delegate GRT tokens to indexers who then earn indexer rewards and query fees which they share a portion with the delegators with. So let's have a look at the architecture of the graph. The graph network is a network of various different nodes, indexer nodes, for example, that are indexing data from multiple blockchains and serve this data through GraphQL compliant HTTP endpoints. And the network tokenomics are settled using the Ethereum network, and the graph has recently switched to Arbitrum, so Arbitrum is also involved here, so that all protocol-related smart contracts function as or to settle payments and to stake, etc. On a side note, micropayments are settled through state channels, but let's leave this out for now. Then let's talk about graph tokens, GRT tokens. GRT tokens are the native utility token of the graph network, and the token of the graph is called graph token, GRT. And the token has been introduced by the graph to ensure that the network is working properly and that there are also incentives for all participants to act in the best interest of the network. And there are different functions that the graph tokens are powering, and these services are really essential, really important, so that the entire protocol can function properly. So one function would be indexer staking. We have already mentioned that indexers are querying data from different blockchains, and in the background, what indexers do is that they stake tokens as an economic security, and they need to deposit at least 100,000 GRT. And this deposit of GRT tokens is then subject to slashing if they act in a malicious behavior. So they are financially incentivized not to behave maliciously, for example, by providing inaccurate data or not being active on the network. Then we have curator signaling. Curators can use their GRT tokens to signal attractive subgraphs. So what they do is curators deposit GRT and mint the curation shares of a given subgraph. And if they are able to correctly predict high quality subgraphs, they will receive a portion of this subgraph's generated query fees. So for example, if a data consumer is querying a specific subgraph, they have to pay fees. And the curators are earning a share of these fees by signaling attractive subgraphs to indexers. Then we also have delegator staking. So the delegators, their primary role is to help to secure the graph network by delegating their stake to an indexer of their choice. And as a reward for doing so, they receive a percentage of the query fees and the indexing reward that an indexer is generating. Then we also have the settlement of payments, which means that payments are settled in GRT tokens. So data consumers of the graph are encouraged to deposit either Ethereum or their preferred stablecoin into their wallet. And in order to consume data from the network, these query payments are settled in GRT tokens. And GRT tokens also function as an incentive mechanism, meaning graph tokens can also be used to provide incentives for certain desired behaviors of the participants in the entire network. For example, the Graph Foundation is giving out grants to developers, to different projects, if they contribute to the Graph network. So let's have a look at the query market. The query market has a similar purpose or serves a similar purpose like an API in a traditional cloud-based application. And this purpose is to efficiently serve data that is required by a front end that is running on a user's device. For example, you have SushiSwap or Uniswap, and you open the interface of Uniswap, and certain data is loaded from the blockchain. And all this data is directly queried by the graph and loaded into your browser, for example. And the key difference to a traditional API that is operated obviously by a single economic entity that may be centralized is that the query market comprises of a decentralized network of indexers. And all these indexers are competing to provide the best service at the best price to data consumers. And in the image, we can see a comparison between a centralized service and a decentralized service. And you can see really well that even multiple indexers going offline would not affect the network, because there's always another indexer that is willing to serve the data as long as there is a demand for querying a dataset and for paying for this data. Meaning that indexers are always incentivized to absorb the additional work that is generated by a given indexer that is leaving the network or that is not active in the network. The pricing of query transactions in the query market is calculated based on the required bandwidth and the compute to process these queries. So some queries are really simple and may not require a lot of bandwidth, while other computations or queries are so large they simply need a larger amount of computation. And this is basically how the pricing of queries is calculated. And for the typical interaction of a data consumer with the query market would be that the data consumer first explores the network to identify indexers that are providing the required data. So they would go into the network, have a look at the subgraphs that are available in the network, and pick the subgraphs that basically provide the data they need. And these subgraphs, the content of these subgraphs, is indexed by the indexers. And then based on a number of different factors, the data consumers are selecting an indexer from whom they want to query the data from. And the selection criteria can be really multifold here, but they can include the pricing strategy of the indexer, the performance of the indexer, the latency of the indexer, data freshness, and many different other factors that are interesting to data consumers. And we've already mentioned the pricing strategies of indexers. So what they can do is to utilize very different pricing strategies to gain an edge over their competitors, over other indexers in the query market, allowing them to attract attractive data consumers who are willing to pay for the data that they are querying from the indexers. And to express their prices, indexers are using a cost model that details the cost of querying the provided data and the prices for additional variables such as database statistics or query features. And from this follows that pricing is not set at a network level, like you have it with a centralized entity who defines all the prices in the network, but it's defined by the demand, supply, and demand of the market. And in times of high query load, when you have a lot of data consumers querying data, demanding data, these indexers can indicate with a flag that their queries are throttled for the market. And to gain a better understanding of the underlying processes of the query market, let's look at how queries and payments are executed. So in figure 1 above on the slide, you can see a query and conditional micropayment. So if a data consumer is interested in the specific data that an indexer is providing, they will send a query in combination with a conditional micropayment to the indexer, asking for their bandwidth and compute. And the query specifies in detail which subgraph they want to query, which data they want to receive from the indexer, and also what block of the blockchain they need the data from. And in the second picture, you can see the response and attestation. So Once the data consumer has asked their price, and once an indexer is found who conforms with this pricing, so meaning the indexer's selling rate conforms with the asking price of the data consumer, the query is processed. And the consumer will then receive the resulting data that comes with an attestation that the data is correct, in fact. And in turn, the indexer will receive the conditional micropayment by providing the attestation. So for the purpose of resolving disputes in the protocol and to provide a purpose of verification, the deterministically produced attestation is uniquely attributable to the indexer, just to make sure that data consumers know exactly which indexer has given out a set of data. And this sounds really complex and time consuming, but what it really does is that all this entire process is happening really, really fast, because consumers define their pricing, define the payment, the price they want to pay, and indexers define how much they want to charge. So these are interactions that are happening in seconds, within microseconds, perhaps even, and on a really, really continuous basis. So this is not a consumer talking to an indexer for hours and negotiating any pricing strategy, but this happens really, really fast. So we've talked a lot about indexers. I think it's time to definitely have a look, or a closer look, at our indexers. So the indexers in the graph network, as mentioned, need to stake at least 100,000 GRT tokens in order to participate in the network, and in order to be able to offer their services to the rest of the network. And the two primary functions why this was implemented is that it provides economic security. So the staked GRT tokens of an indexer can be slashed if the indexer is performing maliciously or is providing inaccurate data to the network, as a security mechanism to ensure every participant in the network is acting faithfully and in the best interest of the network. And also there's a 28-day thawing period during which tokens are locked and cannot be transferred. And this kind of thawing period provides a time frame during which disputes can be resolved, for example, a data consumer disputing the data of an indexer. And this also provides a Sybil resistance mechanism, so the high entry barrier of 100,000 GRT tokens ensures that indexers are highly committed to their work, and it also prevents low-quality indexers without the necessary dedication from entering the graph protocol. Let's have a look at token delegation. Delegators, we have mentioned them already. They are contributing to securing the network by delegating their tokens to an indexer so that the indexer can put the delegated GRT to a productive use. And the role as a delegator is really the ideal role for everybody in a network who just wants to hold their tokens, earn a portion of the generated indexing rewards and query fees in the network, but is not seeking to have an active, dedicated role in the network. And to become a delegator, which is really simple, you can basically just loan your tokens to an indexer, delegate these tokens, and in turn, you will receive a portion of the generated query fees and the indexing rewards of the indexer. And aside from fostering token participation in the network, this delegation mechanism also provides an opportunity for individuals to participate in the network who may lack the required technical background to operate an indexing node on their own. Let's have a look at curation. We've mentioned curators before. They play a really, really important role in the network because data consumers are relying on indexers that index a given subgraph. And you must imagine that in the graph network, there's not just one subgraph or two subgraphs, but there are really hundreds and even thousands of subgraphs floating around with a lot of data that could be indexed. And because of this large number of available subgraphs, indexers in a network need help in identifying quality subgraphs that are potentially promising very high query fees. And to relieve relieve indexers of the burden of identifying this kind of subgraphs, a new role was created in the network, which are curators. And these curators are depositing GRT tokens to indicate to indexers which subgraphs are of a high quality and should be indexed. And doing so helps indexers to better understand which subgraph should be indexed and which not. Then we have developers in the network. These are the individuals and organizations that query data from the network. And developers are the demand side of the graph ecosystem. So they build subgraphs and they publish them to the graph network. And in these subgraphs, they define to the graph what kind of data they want to have indexed from the blockchain. And developers are then querying these live subgraphs that they have created by GraphQL in order to power their different applications, for example, Uniswap. And the developers in the ecosystem are really a key economic actor in the network, and they lock up GRT to encourage indexing. So they lock up the GRT tokens in the network to signal to indexers that their subgraph is attractive and to encourage these indexers to index the contents and the data of these subgraphs. We've already mentioned subgraphs a lot, so let's have a look what a subgraph is. So it's basically really simple. A subgraph is just a custom API that is built on blockchain data. And these subgraphs are queried by using the GraphQL query language and are deployed to a graph node by using the graph CLI. And once they are deployed and published to the graph's decentralized network, indexers are processing the subgraphs and make them available to be queried by subgraph consumers. So as mentioned earlier, subgraphs basically just define to the graph network what kind of data from what kind of blockchain at what time should be indexed. Now let's have a look at how the graph works. The graph network learns what and how to index and which data to index based on subgraph descriptions. So these subgraph descriptions are known as the subgraph manifest. And in the subgraph manifest, it defines for the smart contracts, it defines the smart contract of interest for a subgraph, the events in this contract the graph node needs to pay attention to, and how to map event data to the data that the graph will store in its database. And once you have written a subgraph, or once a developer has written such a subgraph manifest, you can use the graph CLI to store the definition in IPFS and to tell the indexer to start indexing data for that subgraph. Let's have a further look at how the graph works. In this diagram on this chart, you can see the flow of data once a subgraph manifest has been deployed, and the data or the flow is following a total of 5 steps. So first of all, you have a dApp like Uniswap that is adding data through a transaction or a smart contract. For example, from any kind of blockchain, let's say from Base or from Arbitrum or from Ethereum. The smart contract then emits one or more events while processing the transaction. So for example, a transaction is processed on the Arbitrum blockchain, which emits one or more events in the smart contract. The graph node is then scanning the blockchain for new blocks and the data for the subgraph they may contain. The graph node then finds events for the particular subgraph in these blocks and runs the mapping handlers that were provided by the developers. And the mapping is a WASM module that creates or updates the data entities that the graph node stores in response to Ethereum events or other events on the blockchain. And the dApp queries then the graph node for the data that is indexed from the blockchain by using the node's GraphQL endpoint. And the graph node in turn translates the GraphQL queries into queries for its underlying data store in order to fetch this data, making use of the indexing capabilities of the network. And at the final end result is that the dApp is displaying the data in a rich UI for end users, for example, the Uniswap interface, which is then used to issue new transactions on the blockchain, and the cycle repeats. So last but not least, let's have a quick look at why the graph network is in many different ways more efficient, more decentralized and better than self-hosting or picking a centralized provider. So the graph's decentralized network has been engineered and refined to create a very robust indexing and querying experience for end users. And the benefits of this decentralized protocol cannot be simply replicated by having a centralized node that you are running locally on your computer or your infrastructure. So the network as a whole is much more reliable, much more efficient, and less expensive than having centralized or using centralized services. And there are many different reasons why you should use the graph network. So for example, the graph network comes with significantly lower monthly costs. The setup costs for your infrastructure are zero because you don't need any infrastructure. The graph also has superior uptime. There is no outage because basically it's a network of many different nodes all around the world that are providing the data. And the graph gives you access to hundreds of independent indexers all around the world with 24/7 technical support by the graph's global community. So let's have a look at the lower and more cost-efficient structure. There are no contracts with the graph, no monthly fees with the graph. You only pay for the queries that you need, and the average cost per query is $40 per million queries, so really, really small per query. And there are also no setup costs, and which provides you with greater operational efficiency. To get started with the graph, you don't need to host your own server, you don't have to operate any kind of equipment, you just use the network for doing so. So there are zero setup fees, you can get started immediately with the graph, and there's no overhead costs for you to get started, no hardware requirements either. And also no outages, because there is no centralized infrastructure and no single point of failure. Next is reliability and resiliency. So the decentralized network of the graph is giving you access to geographic redundancy that does not exist when self-hosting a graph node. And the queries are serviced reliably thanks to the uptime of the graph network. So the bottom line is that the graph network is less expensive, it's easier to use, and produces superior results when compared to running your own graph node locally. So that's the end of our presentation, that's the end of our workshop. I hope this has helped you to understand what the graph is, and that this workshop has helped you to provide you with an overview about what the graph does and how the future of the graph could look like. So thank you very much for your attention, thank you very much for watching, and see you in the next video.